Hello everyone. Usually, we listen a lot about text mining activities where we calculate number of words and how many times the each word in the textual content repeats. Okay, so let us try something where we can perform some kind of text mining activity and where we can collect number of times the selected word is repeating. Okay, in this text mining activity, we are trying to finish, like I'm trying to finish my assignment, and the kind of requirements are clearly mentioned by the professor in the document. Okay, so requirement document. Based on that requirement, I'm trying to finish this. So basic expectation is a textual, like a set of a data set is given. In that one particular column that contains textual content is selected. Okay, and in that letters that are starting with 4 characters to 99 characters will be considered for the evaluation, and each word, how many times it is repeating, that will be calculated, and based on the type of the based on the values, we will be clustering those data. Okay, so we will take like how like distance between different words, and k-means distance. We take k-means clustering method, and in this, based on the distance value, clusters will be created. All right, so let us start with the data set. I will right click this and click edit. Here we have data set. Oh my. So we can see these are the columns that are given in the data set. So we can see that in that we are taking one textual content here, as we are selecting prose, but we can see this prose is polynomial here. We are supposed to modify it to text, right? So because we conduct text analysis and regular text, no issues with this one. This is a regular text, right? So now I changed it. Simple. This is very important. If it is not, if it is a polynomial, you will definitely experience some kind of errors in the content. To overcome that, we usually use nominal to text operator from the operators to ensure no errors will experienced by you. Right. So now, as I changed it, I am closing this. So this also we can drag and drop here. So this is data. And let me follow the supervisor's requirement. To they are not available actually. So I'm pausing my video for a while and I will start it again. This is my assignment, like where supervisor asked me to perform some kind of activities. So as a reference, I'm creating this video and storing. All right. So now I got some kind of data sets. From this, I took data Amazon employee review, and in the process repository, it was asking me to drag and drop the data set. So I did that. This is dragging, and this is what we call process canvas, and this is my data, and this is operator pen. Okay, so here from here we take all the operators and we drop it over here. This is where my design will be created. Now, so then what he asked is he like let us use some missing values. Maybe we need to replace missing values. Otherwise, if it might get some kind of we use by default average, right? And missing values will be corrected. Then what I do is, like as it was asked by the supervisor, I am taking select attributes operator. This, what it does is it contains multiple columns. When I open this one, you can see that this is no. These all are multiple columns. Now I don't need all those multiple columns. I want to use any one element out of it. So what I do is I will use select operator. So in this select, you can make here it mentions that it is considering all the values. Now I take single. I want to take one single, and I already mentioned it in the early stage of the video that I will be taking cross option, PROS. Okay, I took the PROS option. Okay, next after select, it was asked as professor asked us to. I have selected pros, and then I need to go to process by operators panel and search select process documents. So usually if you don't get any process documents, when you install Rapidminer, by default text mining extensions will not be active. So to get text mining related operators, you are supposed to activate your text mining operators from marketplace. Here by clicking text mining, you get some kind of and searching, you get some operator, some kind of extensions related detail here. You just select them and install them to get those operators, right? Now, as I already installed it, process document from data operator, I have taken it. Okay, now from exe to exe, I have created a link between it. Now I need to create some kind of, well, let me go back. If I click here, I will go back, and this operator I need to check. True method, it is absolute method, and this starts from 2 and it's and still all nines. So in this this is the one which processes the data and transform it into numerical values based on the kind of characteristics we give. So in this first one is tokenize. So I use tokenize. So this takes document, and for this tokenize, non-letter should be selected. So this is what mentioned in the document. So this is already set absolute and 299, and this should be TF-IDF. The next stage I took tokenize now, and it is non-letters. Then I need to take transform paste, TRANS transform paste. Transform cases. So this field is also by default lowercase. Want to change it to something else, you can change, but here it asked us to transform the cases to lowercase. Here clearly mentioned us to mention select lowercase. So I selected lowercase. Then I need to take filter stop. So we are filter stop. Filter stop. Filter stop English words. Okay, we will take filter stop words and English words. So in this, there are no parameters that are defined. And next, I need to take filter key lengths. Okay, operator filter tokens by key length, by length. Filter tokens by length. Tokens by length. This decides what is the size, basic size of the. So usually when you run your code, it starts with a small a and it ends up to z n number of things. So according to this, it is 25 to 25 characters it is calculating. I am taking this 4 and 99 as it was asked. Okay, so now this will be connected to the doc, right? So as of now, I can check this one by running the code to ensure that no mistake is done till now. If any errors identified, we can fix them. So I suggest you to frequently cross-check your design before you run your code. All right, so these are the values, and I didn't generate any outcome. So maybe this is because some kind of issue. What I do is nominal to text I take here, and I will place it on this one, and I will run it again. Sometimes still the content might be different. Okay, I need textual content to process. If you take some numerical content, it won't work. So now I got, you see. Okay, these are the words that are in the given data. We each see, if you take advanced, there are 36 types of occurrences. Advancements, you got multiple types of 179 times amazing occurred, 519 times Amazon occurred. So that's So these are our different types of data that we use. So this is how we can check our design before you complete it. Okay. So I am removing these two things, and now let us use clustering. CLUSTR cluster, and we are using KMeans cluster. So just keep it here. From this we take examples, right? So now let me check this. Okay, sometimes what happens is it won't generate any errors, and here I am taking numerical measures, and in that I will take cosine similarity, right? And this is many clusters I am taking, just 4 clusters. So whatever the data that we have seen last time, different types of words and their number of repetitions, number of occurrences were verified. Based on those occurrences and their mean values and their distance from the mean value, different clusters will be created now. So now let us see if it got any errors. Usually it won't generate any error. Let me check. So if it generates any error, we can correct it. Now it's running. So then what kind of output we get? Let us see. Take some time. I will. Do you want me to pause it? So let me pause. So let us keep it. It might take a few seconds. Oh, it's taking time. I will pause it and I will open when it enters into 90%. Now you can see it is 82% done. So let it get completed. So again, one more time I need to check because still I didn't add any performance related operator. So performance related operator will be added to this one to understand the performance of the used cluster. This is ultimate outcome of the cluster. But here, what we cross check is we should look into this one. These are 4 cluster variables, and these are the attributes that we have. Okay, so based on these, we can understand how different clusters will be created based on the textual data that is created. We can assess this and we can generate some kind of outputs. All right, so we need to make some kind of understanding using these data. So in the next video, I will clearly explain you. But before that, let us test how design can be improvised again to understand performance. So now performance, RMANs performance, cluster performance should be so. Sample is not required, and sorry, curve and clue were taken as outputs. So now let us run it again to get final result of the design. Okay, so this is our design and we estimate it. So this takes some time. So what I do is like while running this one, I will show you. I will stop it here and I will initiate it again. So now all these are executed and we got some results. So let me okay. This is cluster model items. It contains usually 5 items, 5,000 items. Each cluster is divided based on the distance value, and these are different clusters and number of items inside those clusters. Now we got centroid table and we can sort them by increased values. Okay, please take first cluster. What good is having highest relevance and highest number of times it got repeated, and then other things. And if you take highest for this one, it got great and this cluster time is the highest one. So just you can see for each and every data how things getting changed. Okay, so you can sort your cluster values based on the value it got, and you can see in this cluster top is people, in this cluster top is time, and in this cluster top is grade, and in this cluster top is good. Okay, so this is how we can identify and we can rearrange data in clusters. If we take performance, so this is performance. The average centroid distance is minus 0.954 average distance. The cluster, centroid cluster, average within the centroid clusters, average within the distance cluster two. So these are for different clusters. We got 1, 2, 3, 4. This is for overall centroid cluster, and this is for cluster 1, this is for cluster 2, 3, 4. So Davis Balding value is minus 8.786, and this all explains your data. Aditya Sadaka. This is how it works. Now, you got any description? Yes, every detail is here in this. So this is how we assess some kind of details, and the detail related explanation I will show you in the other page. All right. Thank you. Thank you for your patience. Thank you for listening. If you have any queries, please ping me or please comment me so that I can explain you them clearly. Thank you. All the best.